In this example, we're going to find the exact value of a series of logarithmic expressions. You'll note that we're going to do each of these without using a calculator. Instead, we're going to use the basic properties of logarithms. So just as an intro, recall that if we have a function f of x defined by a to the x, so it's an exponential function with base a, then its inverse is going to be this log base a function. So that's a new type of function that we're looking at. And the reason I point this out is that anytime we compose a function with its inverse in either order, we're going to get just x as a result of that composition. So the key property that we're going to use for these examples is that anytime we take log base a of a to the x, we're just going to get x. And let me highlight those real quick. So anytime, and notice that the bases have to match. So anytime we compose log base a with a to the x, we're just going to get x. So let's look at this first example. We have log base 5 of 25. Now 25 isn't actually written with base 5, so in order to use this property, we need to make sure that what's inside that logarithmic expression is written with the same base. So we'll take log base 5 of 25, and we'll write that then as log base 5 of, and we'll write that 25 with a base of 5. So that's going to be 5 squared. And now, as we see, this expression, log base 5 of 5 raised to the second power, will just equal 2. Now, as we look at this, I'm using the property of logarithms based off the fact that this logarithmic function is an inverse. Another way that we can look at logarithms is to say, when we see this log base 5 of 25, is 5 raised to what power gives us 25. So what we're really looking for here is the exponent on 5 that will result in 25. That's an alternate way to look at these. All right, in our next example, we have the natural log of e to the 5th. And this one is actually quite a bit simpler than it probably looks. So we need to figure out the base here. And the natural log function, remember that that's just log base e. So if we rewrite this with log base e of e raised to the 5th, we can quickly see then that the natural log of e to the 5th is just going to be 5. All right. Now, with these next few, we might have to do a little bit more algebra in order to get them written with the same base as our logarithm. And this is a good example here. We have log base 2 of 1/16. So in order to evaluate this, what I want to do is look at writing 1/16 with a base of 2. And so I can do that in one step or in a couple steps. I'll do an intermediate step here, and I'll write the 16 with a base of 2. So looking at writing 16 with base 2, I'll write 2 raised to the 4th, as 2 raised to the 4th is 16. And then I can also note then that that will mean that this 1 over 2 to the 4th is 2 to the negative 4th. So when I write 1/16 with a base of 2, it's 2 to the negative 4th. And as we look at that then, let's color code that out. Log base 2 of 2 to the negative 4th will just give us negative 4 then. All right, coming down to this example, we have log of 1,000. And with this one, we have the common logarithm. So just writing log automatically means that our base is log base 10. So I'll write that in just to be explicit with it. And this 1,000, looking at writing that with exponents, I need a base of 10. And that shortcut rule is that I can just count the zeros. So I've got 10 to the 3rd. And so when I simplify that through, we'll just get 3. So log of 1,000 is going to be the number 3. All right, next we'll look at log base 4 of 1, and there is a general property for this logarithm, but let's look at why that holds true, and then I'll state the general property. So log base 4 of 1, it's hard to think of 1 written with base 4, but there is a property that any base a raised to the 0 is going to give us 1. So the way that we'll rewrite this one in order to evaluate it is to think of it as log base 4 of 4 raised to the 0. And now we can see then that log base 4 of 1 will just give us 0. And the general property that we see there is that log base a of 1 is going to be 0 no matter what that base is. All right, in our last example, we have log base 6 of the square root of 6. And this one is a little tricky at first to think about writing with the base of 6. But the key here is going to be to use rational exponents. So if we look at log base 6 of that square root of 6, in order to evaluate this, I need that square root of 6 written with a base of 6. So what I'm going to rely on then is that that square root can be written as, instead, as an exponent of 1/2. So I'll have log base 6 of 6 to the 1/2. And so when we evaluate that, we just get 1/2. So log base 6 of the square root of 6 is then equal to 1/2.